Good afternoon to all IEM and UEM family members. So we are back again, and today Professor Somen Nayak from the Department of Computer Science and Engineering of University of Engineering and Management, Jaipur, will be presenting breast MRI registration using meta-heuristic algorithms. Somen is a good researcher. He himself organizes 2 conferences almost single-handedly. So I'm sure that Shoman will come up with a wonderful presentation. He once used to be a student of IEM. Now he is doing very good research, which feels very good for me. So Professor Shoman, you may kindly take over from here and present your topic. I'm very excited to hear this.
Thank you, sir. Sir, am I audible, sir?
Yes, you are audible and visible both. You may continue.
Okay, sir. Good afternoon to all IEM and UEM family member present over here. Today, I am in front of you to present my research work. The title of my research work is Breast MRI Registration Using Meta-Heuristic Algorithm. Before I deliver the content of my research work in a very detailed manner, I would like to tell you that what are the areas of my research work that I am going to cover in this particular session. So very quickly, I would like to read the areas of my research work that I am going to cover in this particular session. So first of all, I would like to discuss about the abstract of my research work. Then after that, introduction, proposed method, and resultant discussion, which is the most important part of my research work, then conclusion, future scope, and lastly references. So let's begin with the abstract of my research work. In a survey, it has been found that 10% of the women are suffering from breast cancer in their life. So breast MRI registration is going to be one of the important techniques through which we can diagnose the cancer and classify the type of cancer. Whether the cancer is a malignant or benign, that we can able to classify with the help of that technique. In this research work, breast MRI registration using MVO stands for Multiverse Optimization Algorithm, and SPVO stands for Student Psychology Based Optimization Algorithm is proposed, and MVO and SPVO are the meta-heuristic based optimization algorithm which we have applied to register breast MR images. In that, to conduct that experiment, I have considered 40 pair of breast MR images of pre and post modalities. After that, the images are registered using MVO and SPVO algorithm. The result of the SPVO based breast MRI registration method are compared with a MVO based breast MRI registration. After that experimental result that I have obtained, I can able to infer that the SPVO based registration method statistically outperforms, or we can say that statistically performs better as compared to the MVO based registration method in breast MRI registration. So that's all about the abstract of my research work. Now I am coming to the introduction part of my research work. Before I'm going to talk the content of my research work in a very detailed manner, first of all, we need to understand that what is breast MRI registration. It is actually a mechanism to align various MR images of breast based on their feature. In breast MRI registration, corresponding feature of the breast images have been extracted to detect the physical space. In breast MRI registration, two concepts are very much important. The first concept is transformation and second one is mutual information. So let's have a look at what is transformation. Transformation means changing some graphics into something else by applying rules. We can have a various type of transformation such as translation, rotation, scaling up and down, and shearing. These are the various or popular type of transformation that we are having in the subject of computer graphics. So when a transformation takes place on a 2D plane, it will be called it as a 2D transformation. And when the transformation takes place on a 3D plane, we will call it as a 3D transformation. So to perform a sequence of transformation such as translation followed by a rotation and scaling. That means what? Whenever we are going to perform or we are going to follow the sequence of transformation, first of all, we are going to perform translation, and after that, it will be followed by rotation and scaling. So the sequential process starts with the translate the coordinate, right? That means translation. The sequence of process starts with a translation of the coordinate. So let's see how the coordinates are being translated. So translation means, before I come to the come to explain that what is translation in a detailed manner, I would like to tell that what is translation. A translation is basically a moving an object to a different position on a screen. That means what? If an object is present over here and it has a named as P, which have a coordinate called x comma y, and if you are moving that particular point from here to that particular place, that is called P dash, and whose coordinate is x dash comma y dash, then translation, then how can we write the expression of the translation? First of all, we need to measure the distance from this point to that point with respect to x-axis. So if the distance, if I will suppose that let us suppose that the distance from this point to this point with respect to x-axis is tx. Okay, so if we find out the expression, if you write the expression for x dash, then x dash must be written as x plus tx. And if we are suppose write the expression for the y dash, then y dash will be written as y plus ty. Okay, so this is the expression that we are going to write for that translated for that destination point. So tx and ty will be called as a translation vector or a shift vector, and the above equation, that means this equation, will be represented as a column vector. So if we represent that expression in a column vector, then that should be the expression for the column vector, and this column vector will be written as p dash equal to p plus t. Okay, so this is the mathematical stuff which is related to the translation, which I have included in my research work. Now I am coming to the part called rotation. In rotation, we rotate the object at a particular angle called theta. So let understand what is rotation with the help of a diagram. So you can see that here, this is the object. Okay, object means here I am talking about MRI registration, so I will call that object as an image. Okay, so it is actually resides in a two-dimensional plane with a angle called phi. Now I am rotating that particular object from phi to theta. Then what should be the expression for x coordinate? For x coordinate, if we are writing the expression for the x coordinate, then it should be straightforward r cos phi. And if we are writing the expression for the y coordinate, then it should be written as y equal to r sin phi. That will be numbered as equation 1, and that will be numbered as equation 2. Now the destination, or the destination point or the destination coordinate can be written as x dash equal to, because the object is rotated from phi degree to theta degree, so it should be written as r cos theta phi plus theta. Okay, the total angle I need to consider. So The expression should be written as r cos phi plus theta. So if we expand this expression with the help of a formula or with the help of a trigonometric formula, that is cos a plus b, that is the expression which I am getting. So it should be marked as the equation number 3. Now, similarly for y dash also, I need to find out the expression. So what should be the expression for y dash? Y dash equal to r sine phi plus theta. Then if we expand that particular expression with a trigonometric formula called sine a plus b, then we are getting that particular expression, and which will be marked as a equation 4. Now I am substituting the value of 1 and 2 in that equation 3 and 4. So what should be the expression that I will get after substitution? After substitution, this one is the expression that we will get after substituting the value of 1 and 2 in equation 3 and 4. So if we write that particular expression in a matrix format, so this one is the representation of matrix format of that particular expression, and which is also been represented as a p dash equal to p dot r. So finally the rotation matrix that I am getting is this one, which I have included in my experiment. That logic is completely been implemented in order to pursue my research work. The rotational angle can be positive or negative. Anything can be happened with a rotation angle actually. Now the next important concept that I am having for my research work, that is called mutual information. Mutual information is nothing but a measure of image matching. Image matching means what? Suppose this one is my first image and this one is my second image, right? Now I am going to superimpose that two image. So whatever the similarity measure of the images are, that is known as actually the mutual information. So the formula for the mutual information, or the formula for computing mutual information, sorry that I have not included the formula in that particular slide, so I am writing that formula here. So mutual information for two images A and B will be written as entropy will be denoted by H, entropy of the first image plus entropy of the second image subtracted by joint entropy of both the image. So this is actually the expression to find out the mutual information. So I am requesting Professor Dr. Bishwa Chatterjee sir to please post the audience poll, and audience are requested to please answer that poll.
Okay, so I have already posted the poll, and we will wait for 1 minute again for the answers. We are into the 14th second. I request all members to vote. It's around 30 seconds. We have received 37% votes. I request all members to vote at your earliest. The question is very simple. A growing application of MRI is MRA, which stands for what? Okay, so we are into the 54th second. Voting is less today. I don't know why, but it's around 45% votes till now. 1 minute over, and we are into 46% votes. I close it and I share the results. So with 48% votes, the result is 59% people says magnetic resonance amplification. 33% goes for magnetic resonance angiography. 4% for minimal radiology applications, and 4% medical research assistance. Okay, So, Professor Somen, your take, please.
It is the correct answer should be angiography, means option B, I think.
Okay, so 33% people went for that correctly. So this is a very straightforward question anyway, but maybe we are not too much acquainted with this medical term. So Professor Somen, you may take over from here. I hide the results.
Okay, sir. Thank you, sir. So now I am going to talk about the proposed method of my research work. So proposed method, I have proposed two different algorithms, that is SPBO algorithm and MBO algorithm for registering 40 pair of breast MR images. Now the question comes, why I have used that particular algorithm and what is the job of that algorithm? So I have already explained the concept of translation and rotation. So total two parameters are there for translation and one parameter is there for rotation, right? So for two parameter of translation, that is x and y, and for a rotation there is one parameter that is called theta, right? So to manage or to optimize that three parameter in case of breast MRI registration is going to be a very challenging task for the success of that experiment. So this algorithm, actually the algorithm called SPBO, student psychology based optimization algorithm, and multiverse optimization algorithm, is going to optimize that three parameter which is related, which is actually called as a parameter for translation and rotation. So this algorithm called SPBO is based upon the student psychology of scoring good marks in an exam. And this particular algorithm called MBO is actually based upon the concept of black hole. So that is the two algorithm which I have proposed in order to register 40 pair of breast MR images. Now I am coming to the part of result analysis. It is going to be a very interesting result actually. So for a data set, I have actually created a data set of 40 pair of breast MR images, right? And each and every algorithm for each pair of images, each and every algorithm is run. I have taken 10 independent run for each and every pair of images. So if we are taking 10 independent run for each pair of images, then I have a 10 different values of for mutual information. So for 10 different values for the mutual information, I have computed the mean as well as the standard deviation for each and every for every pair of the images that I have been registered. Okay, so here you can see that the bold face digits are the mean bold face digits denoted the mean that I have obtained after executing or after registering the image with the SPBO algorithm, and the within the digit or the numeric thing that is written or that is enclosed in a bracket, that will be called as, that will actually a standard deviation. That is actually the standard deviation that I have computed after registering it with the SPBO algorithm. Okay, so larger the mean signifies that this algorithm performs better as compared to the algorithm called MBO. Here you can see that if you compare the mean of both the algorithm that I have taken into the consideration for my experiment, you see that for a 39 pair of images, SPBO algorithm gives a larger mean. So that means what? That actually concluded that SPBO algorithm performs better as compared to MBO algorithm. So that is actually the quantitative analysis of the result. And now I am going to the qualitative analysis or the visual analysis of the result. So you can see that here there is two raw MRI images of two different modalities. This one is a pre-modality. This one is the MRI image of pre-modality, and this one is the MRI images of post-modality. Now I am going to register that two image by using MVO algorithm. So this is the output image that I am getting after registering that two image with a MVO algorithm, and this is the output image that I have got after registering with a SPVO algorithm. So this is actually the qualitative or the visual result of the experiment that I have conducted, and 40 pair of images are not been possible to include in this presentation, so I have included some of the images. So these are the raw MR images of pre and post contrast, and these are the output images that I have got after conducting the experiment. So that's all about the result analysis part. Now I am coming to the conclusion part. In this research work, breast MRI registration using SPVO and MVO is proposed, and this proposed method, SPVO and MVO, is handed down for piercing the optimal transformation parameter which are used for registration of the breast MR images. The achievement of the SPVO algorithm is compared with a MVO based technique. Okay, so I have already been explained that the achievement of the SPVO is compared with the MVO based algorithm. So both the quantitative as well as the visual result are also been compared, and the method that we have proposed. Okay, now in that particular conclusion, I have already told that from the mean part that I have already observed, from that mean part I can conclude that SPPO algorithm or SPBO based registration method statistically works better as compared to the MBO based registration method in case of breast MRI registration. So that's all about the conclusion part. Now I am coming to the future scope of my research work. In future, we are going to use the proposed method in the registration process of breast tumor progression. Okay, so this algorithm or this technique can be used for the tumor progression also, whether it is related to the breast organ or whether it is related to brain. We can apply it in any of the organ present in the human body. So we will also study the various. There are a lot of meta-heuristic algorithm present in the market, like particle swarm optimization, fireworks optimization algorithm, and moth flame optimization algorithm, whale optimization algorithm. There are many optimization algorithm or meta-heuristic algorithm that are present in the market. So I will study all of the meta-heuristic algorithm and try to implement it in breast as well as brain MRI registration. In this research work, the experiment is been carried out for 2D MR images of breast, right? And in future, we are going to propose it, or we are going to apply it for 3D MRI in future study. So that's all about my future work. So these are the references that I have used to conduct my research work. Thank you, everyone, for listening me. If you are having any question related to my research work, I will be happy to answer.
Yes, there is one question I can see in the questions panel, but prior to that, I must say that it was a good presentation, nice and short, and you went quite deep into the topic without making it too much difficult. So that was good from our side, I believe. The question is from Professor Arun Kumar Chatterjee, who asks, is the term entropy that you have used same as the one you defined in thermodynamics?
No, it is Shannon entropy. Okay, for finding out the formula of a mutual information that we are using, the entropy that we are using for the for measuring the image matching, that is called Shannon entropy that we are using.
Okay, but I believe the term entropy comes from the same meaning, disorder. Like,
Definitely.
I believe it's the same.
Definitely, sir. Definitely, sir.
Okay, so Professor Iqbal continues the question asking what is entropy signifying here. It seems that the mechanical department people have got a little bit of issue with the term entropy, but let me also tell you from a computer science point of view, entropy means the same, it's the disorder. So you use it in thermodynamics or use it in some other term, it should mean the same, the disorder should be meant. Professor Somen, your take please.
Sir, see, entropy is actually if you want to calculate the entropy of an image, now it is going to be a very time consuming task. If I want to explain you here, so I will share the email ID with you definitely. So if you want me to explain, I will. You please definitely contact with me. I will definitely try to explain what is how the entropy of the image are been derived from. If a particular image are there, then how we can derive the entropy of a particular image. I will definitely explain you.
True. Okay. So yes, that will be interesting. Professor Jyoti Khandelwal writes, entropy is the similarity between two images. If it is near
Definitely,
to
it is a similarity between two images.
images,
But
if
the cal yeah,
just a minute, if it is near to 8, it is known as the best solution. That is a comment she is making. Yes.
yeah. But there is a lot of mathematical stuff for calculating those the entropy of a particular image. That's the reason I'm telling it.
Right. Dr. Subroto Chattopadhyay compliments by saying it's an excellent research. Professor Arun Kumar Chatterjee has got one more question. He asks, can this algorithm detect the proximity of lymph nodes from the cancerous course?
Sir, see, actually, I have implemented on breast MR images. Okay, I have not yet implemented on lymph actually. So I need to implement it. Then I have to see whether that algorithm is detected or not. That algorithm detects the cancerous cell in the lymph node or not.
Okay, but interesting is nowadays people have started believing that all algorithms can be used for all purposes. Only it is the trick that we need to change here and there. So that is a very important and interesting comment that people are making nowadays. Anyway, thank you, Professor Somen. Oh, there is one more question now. Professor Shubhobroto Sengupta asks you, entropy and mutual information will be used in image classification and segmentation. He asks that whether entropy and mutual
It
information.
is used in image segmentation also.
Yes. Various segmentation techniques are there. Yes, definitely. And as he has already answered that in segmentation also the term entropy and mutual information will be used. Okay, thank you, Professor Shubhobroto, for that question. Thanks to all IEM and UEM family members. And thanks to Professor Somen. Thank you.
Sir.
We'll meet again tomorrow. Thank you.